Piecewise functions are an interesting way that we can start taking many different functions and put them together all into one function. And the big idea here is that we're basically going to take pieces of other functions and stitch them together when we make this new one. So below I have an example of what one of these piecewise functions looks like. And you want to start breaking down the different parts of this piecewise function. Some of the first parts are those places like x squared, 4, and x minus 1. Those are basically the behaviors of this piecewise function, or the individual pieces from other functions that it's using. So it looks like this guy looks like x squared, it took a piece 4, and it took x minus 1. Now those inequalities that you see on the right, those are basically intervals of where the function takes on these individual behaviors. So it looks like x squared when you use x values that are less than -1. And it looks like 4 when you use x values between -1 and between 2. To get a sense of what this piecewise function will look like on the entire graph is to first start with each of those individual behaviors and put them on the graph individually. So here I've taken x squared, 4, and x minus 1 and used my graphing techniques to see what each of them look like individually. Now we're going to basically take pieces of all of these, stitch them together, and make our piecewise function. In order to know which of the pieces goes on which parts of my graph, I also examine the behavior of my piecewise function and basically split it up into certain intervals. So remember that our intervals are that x is less than a -1, x is between -1 and 2, and x could be greater than 2. So I'm using these two vertical lines here just to represent different sections of the graph. Now on the first section on the left, I basically want to put that x squared part. So remember what it looks like, basically a U shape. Now I don't want the entire thing, I just want the part that falls on the left side or when x is less than -1. So with the rest of that U shape, I imagine getting rid of it entirely. So I just have the left side of that U shape and it stops at -1. Now notice how I've put a big open circle at -1. That's because when you look at that interval, it says that x is strictly less than -1, but does not equal -1 when you're using x squared. Now, we want to go through the same process for all the rest of the parts. So, my function acts like 4 between -1 and between 2. And it acts like the line, x minus 1, when I start using x values greater than 2. So, I would put those parts on their individual pieces of the graph as well. So altogether, I have a picture of what my piecewise function looks like. And as you can see, it's broken up into lots of different pieces. On that first section, it kind of looks like x squared. In the middle, it looks like the line 4. And on the right, it looks like the line x minus 1. One last thing that you might want to know about piecewise functions is simply how to evaluate them. In other words, if I give you a certain input, how do you know how to give me a certain output? Well, the basic idea is to know which piece of the function you're using at any given time. So let's take an example. This is that piecewise that we graphed before. And I want to find different values like f of -3, f of 1, and f of 10. Now, inside each of the parentheses down below, like f of -3, that's essentially giving me information about my input. So let's take the first one, f of -3. Well, this says I'm taking an input of -3. Look at your behaviors to see where -3 falls. Is it less than -1? Is it between -1 and 2, or is it greater than 2? Well, -3 is less than a -1. So I know to use this -3 in the first piece, the x squared. So imagine taking a -3 and squaring it. This will give us an output of 9. See, not too bad. As long as you know where to evaluate it, you can use the behaviors to essentially take care of the rest of it. All right, let's do the same for 10. Notice how 10 is greater than 2, so it gets plugged into the last piece. And I'd take 10 minus 1 to get an output of 9. And finally, f of 1. Well, since 1 is between -1 and 2, I would use the middle piece. Now this one's kind of tricky because you notice that middle piece doesn't have an x in it. It's just simply 4. Well, the good news is when we go to try and put it into that piece, it's essentially just 4. So there is no place to really plug it in, and if I pick any value between -1 and 2, the output is always 4.